Double angle, reduction of power, and half angle formulas. We know that the sine of x plus y, this is one of the ones that we're going to memorize, is the sine of x cosine of y plus the sine of y this should be y, excuse me, times the cosine of x. Now, if I let y be x, so I have the sine of x plus x, which is the sine of 2x. So I get sine x times cosine x, because y is x, plus sine x, because y is x, times cosine x. Ooh, look at this. I'm adding those two very complicated looking expressions. But I know one thing. If I have two of them, whether I like what it looks like or not, I'm going to end up with two of them. This is a formula that you can get for free by just letting y be x. Okay. The other formula that you can get for free comes from this one. We remember what the cosine of x plus y is. It's the cosine of x times the cosine of y minus the sine of x sine of y. This formula we remember, that formula we remember. Now, if we let y be x, then we'll have the cosine of x plus x, which is the cosine of 2x. So you have cosine x times cosine x. That's cosine squared x minus sine x times sine x. That's sine squared x. That is one way of writing the cosine of 2x. But there are other ways. Sine squared x is 1 minus cosine squared x, because sine squared x plus cosine squared x equals 1. And if you bring this to the other side, you will get that sine squared x is equal to 1 minus cosine squared x. So that's another way of writing sine squared x. Just bring this to the other side. So we get cosine squared x minus 1 minus negative cosine squared x, which is cosine squared x. Well, cosine squared x plus cosine squared x is cosine squared x. Don't forget to take away 1. That's another way of writing the cosine of 2x. But you know what? There's another way. Instead of replacing sine squared x, we can replace cosine squared x. Just bring that to the other side. And then we get cosine squared x is 1 minus sine squared x. So this cosine squared x is 1 minus sine squared x minus the other sine squared x. That is, it's 1 minus 2 sine squared x's. There are 3 ways of writing cosine 2x. Personally, I guess from doing it enough, I remember the top one. I never remember those two, but I easily get it. Cosine of 2x is both of those. Now, the tangent of 2x, well, that's just the sine of 2x over the cosine of 2x. Sine of 2x is 2 sine x cosine x. And one way of writing cosine 2x is cosine squared x minus sine squared x. There it is. That's the tangent of 2x. You want to remember these formulas? That's fine. Just for the record, in terms of tangents, this is our 2 tangent x over, guess it's going to be 1 minus tangent squared x. You want to remember this formula? Fine. Keep in mind, there's a limit to how much you can remember. Maybe you can remember it for the exam, but in 4 years from now, you're not going to remember it. But I still can get this. I still can get that. In fact, I can get that pretty easily. Since I want tan x in the numerator, we have this in the numerator, and we have this in the denominator. Well, if I want tangent x, 2 tangent x, so I have the 2. I need to divide by, so there's the 2. This over that gives me the tangent, but then I want to kill that off. So I'll divide by another tangent, and the tangent will get killed off. And then I have to divide the denominator by cosine squared x. Now, if you like, you can think of that cosine squared x as cosine x times cosine x. There's my 2. This in the middle is tangent x times 1. 2 tan x times 1 is 2 tan x. In the bottom, that's 1 minus, and sine x over cosine x is tangent x. But I'm squaring it. There it is. I can get that formula. If you insist that I write it, I can easily derive it. So we have these formulas. Now, we talked about reduction formulas. We know that cosine of 2x, well, let's just have you see it. Cosine of 2x is either this, that, or that. Ooh, we went from 2x's being the angle to x being the angle. One calls that reduction formula. Same thing with sine 2x. We know that the sine of 2x, so the angle is 2x, is equal to this. But the angle got reduced. The angles here are now only x. We went from taking sines and cosines of 2x, and now we're only taking it of x. Okay? So that's what we call the reduction formulas. So, for example, if you wanted to, we want to write, say, the cosine of 4t. The cosine of 4t with only the angle t. Well, cosine of 4t, well, 4t is 2 times 2t. And the cosine of 2 times an angle is cosine squared of the angle minus sine squared of the angle. Now, cosine squared of an angle, how much does that equal? what we can do is, let me try to do it over here. For example, we know that cosine of 2x is, say, equal to this. So the cosine squared x minus 1. So we can reduce that. Well, cosine squared of u is okay, let me just get this. I don't know why I'm fumbling. We know that cosine of 2x is equal to cosine squared x minus sine squared x. And I can replace the x's with t's. And then I get that this is cosine squared t minus sine squared t squared minus sine of 2t is 2 sine t cosine t. But this gets squared. Now, when I square this, I get the first squared minus 2 times the first times the second plus the second squared, sine 4th t, minus 2 squared sine t squared cosine t squared. And I can combine some terms. I get cosine to the 4th t, that's that, plus sine to the 4th t, and then I take away 2 of these, and then I take away 4 more. I took away 6 sine squared t's, cosine squared t's. Okay, so I reduced cosine of 4t to just trigonometric functions involving just the angle t. Doesn't matter that it only involves sines and cosine. Could have involved any trig functions that came up. Now, we want to derive the half angle formula. We know, for example, that cosine of 2x is equal to 2 cosine squared x minus 1. I want to solve this for cosine x. So first, I'll solve for cosine squared x. Actually, first I'll solve for 2 cosine squared x by adding 1 to both sides. On the right side, I just have 2 cosine squared x. Now, on the left side, I don't want to write it like this, because somebody might think that I mean that the angle is 2x plus 1. Just so nobody confuses that, I'm going to write the 1 plus in front. Nobody should dare think that this equals cosine of 2x plus 1. That is not the angle. It is, I won't say it's unreasonable to think that the angle here is 2x plus 1. Okay, so I'll write 1 plus cosine of 2x. Of course, now I'll divide both sides by 2. So I have that cosine squared x is 1 plus cosine 2x over 2. So cosine of x is plus or minus 1 plus cosine 2x over 2. Now here's how you get this to be the half angle formula. If I take half of that angle, I get cosine of u over 2. So I'm let u be 2x. Forget what I wrote on the left for a moment. This will be 1 plus cosine, well 2x is u over 2. And if 2x is u, dividing both sides by 2, I get that u over 2 is x. And instead of x, I put u over 2. This is the half angle formula. Okay, we'll talk about what that means in a little bit, how you use it. Now, we also know that cosine squared x is, cosine 2x. That's 3 ways of writing cosine 2x. And one way was 1 minus sine squared x. We want to solve for sine x. So first, since it's minus sine squared x, I'm going to interchange those two. So 2 sine squared x is 1 minus cosine 2x. Divide by 2. Sine squared x is the right hand side over 2. So that tells me that sine of x is plus or minus 1 minus cosine 2x over 2. And once again, I'm going to call that u. 1 minus cosine of u over 2 square root. Well, if that's u, well then that's half of u. That's u over 2. And there is my other half angle formula. Now, what this enables me to do is to find, we know the sine of we know the trig functions of 30 and 45. Well, what if I asked you, what is the sine of 15 degrees? Now, we did do this earlier with their sums and difference formula. But now we can use the half angle formula. 30 degrees is 30 over 2. That u is 30. Well, so is that u. This gives us plus or minus the square root of 1 minus cosine of 30 over 2. Now, we know the cosine of 30. At least we can figure it out. But first we need to decide, is there plus or minus? The whole answer. Well, we're in the first quadrant. And the sine of an angle in the first quadrant is always positive. So much for not knowing what sign to use. Okay, now, if you know the cosine of 30, wonderful. If you don't, you at least have to know this triangle. 30, 60, 90, 1, 2, square root of 3. The cosine of 30 degrees is adjacent over hypotenuse. So it's the square root of 1 minus square root of 3 over 2 over 2. Now, you really shouldn't have denominators in your numerators. In this numerator, we have a denominator, it's 2. So how about we multiply top and bottom by 2. 1 times 2 is 2 minus square root of 3 over 2 times 2 is just square root of 3 over 4. Oh, I know the square root of 4. So the final answer is 2 minus the square root of 3 over 2. Now, I'm almost positive we got a very different answer earlier. Okay, so write down what we got and convince yourself that they're equal. Use algebra to figure it out. Now, suppose we wanted to find the cosine of 22.5 degrees without a calculator. And you're like, oh my goodness, how do I do that? Well, that's half for 45. This is the cosine of 45 over 2. And the cosine of x over 2 or u over 2, we know what that is. It's plus or minus the square root of 1 plus cosine u over 2. But I'm pretty sure that we have, okay. All right, so it's cosine, 1 plus cosine u over 2. Well, that's my x. I mean, they both have a C, they both have an O, they both have an S, they both have this division line, they both have this strange symbol in the bottom that most people call 2. Oh, those must be equal. X is, oops, that should say x here. X is 45 degrees. Now, the cosine is positive 22.5 degrees is in quadrant 1, and all trig functions, including cosine, is positive in quadrant 1. So we get 1 plus the cosine of 45 degrees over 2. 45, 45, right triangle, 1, 1, square root of 2. We can use this angle. The cosine is adjacent over hypotenuse. So it's 1 plus 1 over square root of 2 over 2, the square root. No denominators in my numerators. So I'll multiply top and bottom by square root of 2. Square root of 2 times 1 is 1, plus square root of 2 times 1 is the square root of 2, plus the square root of 2 times 1 over square root of 2 is 1 over 2 square root of 2. Okay, there is your answer. There is your answer. Okay, some people may say, nope, your denominator can't have square root signs. Fine. We'll multiply the top by square root of 2 and the bottom by square root of 2. The denominator, well, square root of 2 times square root of 2 is 2, times another 2 is 4. Square root of 2 times square root of 2 is 2, plus square root of 2 times 1 is square root of 2. And I do not know the square root of the numerator, but I do know the square root of the denominator. That is their exact value to any decimal place you like for the cosine of 22.5. You can't, unless I made some silly error, that is the exact answer. You cannot get any closer to the answer than that. Okay. Suppose you were asked the following question. Suppose you were told that the sine of x is 3/5. X is in quadrant 1, and you were asked to find the sine of 2x, the cosine of 2x, and the tangent of 2x. I would first draw my triangle. This is angle x because you take sine of angles and you get the opposite over the hypotenuse, or in that ratio. And you should realize, oh, this is a 3, 4, 5 right triangle. And now you just need to know your formulas. Sine of 2x is 2 sine x cosine x. Well, I know 2 sine x, you can either say it's opposite over hypotenuse, or you can say they gave it to us. Either way, you should get 3/5. The cosine of x, well, we needed the 4. It's adjacent over hypotenuse. It is 4 over 5. So you get 24 over 25. The cosine of 2x is cosine squared x minus sine squared x. Well, cosine x was 4/5. We square it, we get 16 over 25 minus sine x was 3/5. We have to square it. So we get 7 over 25. The tangent of 2x, well, when we have the numbers in front of us, so rather than using the tangent formula, I'll use sine 2x over cosine 2x. Sine 2x is 24 over 25. Cosine 2x is 7 over 25. The 25's cancel. If you multiply the top and the bottom by 25, you would get 24 on top and 7 on the bottom. That is the tangent of 2x. Found the cosine of 2x, the sine of 2x, and the tangent of 2x, just given this information and drawing this triangle, which helped me figure out the 4. Let's try another problem similar to this. They tell us that the cosine of t is 12 over 13. The cosine of t is 12 over 13, and the sine of t is bigger than 0, and the same 3 questions. Find the sine of 2t, the cosine of 2t, and the tangent of 2t. Well, the cotangent of this angle is positive. Cosine deals with adjacent over hypotenuse. Hypotenuses are always positive. The adjacent are only positive in quadrant 1 and 4. So we know, based on just this statement, that t is in quadrant 1 or quadrant 4. The sine of the same angle t is positive. Well, sine deals with the opposite. The opposite is positive in quadrant 1 and quadrant 2. So t is in quadrant 1 or quadrant 2. But this is an and here. Both of these statements are true. It is and. That is, If I tell you today you're in quadrant 1 or quadrant 4, and tomorrow I say, you're either in 1 or 4. Well, you're in 1. That's the common answer. See, if you're in 4, you satisfy this statement, but you didn't satisfy that statement. For and to be true, this must be true and this must be true. Or is different. Or means one of these must be true or both. And means they're both true. So we are in quadrant 1. Okay, so that made things a bit easier. We are in T is in quadrant 1. And the cosine of T is, 12 over 13. Okay, so 12 over 13. You should know that 5, 12, 13 is a Pythagorean triple. If you didn't, let's call it y. You know that Pythagoras will tell you 12 squared plus y squared is equal to 13 squared. I bring that to the other side. We get 13 squared minus 12 squared. Oh, it's the difference of squares. We add the things that are being squared times. We subtract the things being squared. We get 25 times 1, which is 25. So don't tell me you don't know what 13 squared is. You don't have to know it. So if y squared is 25, y is plus minus 5. Since y is going up, it's positive. Okay. So let me just get this out of the way. So just like before, the sine of 2t is 2 sine t cosine t. 2 is 2. Sine of t is, well, it's opposite over hypotenuse. It's 5 over 12. The cosine of t, it's adjacent over the hypotenuse. Put down the wrong value for the hypotenuse the first time. That's cosine of t. Or you can read it off. They told us it was 12 over 13. Well, 13 times 13 is 169. 2 times 5 is 10. And 10 times 12 is 120. We now have the sine of 2t. The cosine of 2t is cosine square t minus sine square t. Well, we know the cosine of t, so it's 12 over 13 squared, minus, we know the sine of t, it's 5 over 13 squared. They're both fractions have 13 squared, so it's 169. It's 12 squared minus 5 squared, which is, I think, 119 over 169. Looks right. And I don't, yeah, that's not factorable. Yeah. Okay. And the tangent of t, the tangent of 2t, well, it's the sine of 2t divided by the cosine of 2t, which is just 120 over 119. And that problem is done, and this completes this segment of trigonometry video, the one entitled Double Angle, Reduction of Power, and Half Angle Formulas. try to memorize as few as possible. And of course, be able to come up with the others on the spot quickly. If for some reason you can't come up with it quickly, then you're going to have to memorize them. Good luck.